What if I told you there's a type of math that doesn't just describe the world, it creates infinite ones? From galaxies to video games, snowflakes to surreal digital landscapes. All of them are shaped by a few simple formulas. This is the secret math behind infinite worlds. To begin, how do we actually generate a world? First, let's create a random map composed of pixels in a 3x3 grid. We can represent different depths with these pixels. For instance, black would indicate the deepest point, at 4 blocks below the maximum height, while white would represent the highest point. The darker the pixel, the deeper it is, and the lighter the pixel, the higher the elevation. So, basically, all we have to do is generate a 2D image and make it smooth enough so that the terrain generation makes sense. If we try this on a 10x10 grid, well, then it becomes more chaotic. So, how do we make a 2D image that is smooth, makes sense, and is still random? That's where Perlin noise comes in, and so I searched up a guide on how Perlin noise works and yeah, it's kinda confusing. I mean, you gotta make a square, then make 4 random vectors pointing somewhere. Then choose a point inside that square and dot product. So I looked at an image of what Perlin noise is supposed to do. And most websites just tell you that it smooths out random numbers, like this graph from Khan Academy. I'm probably misrepresenting what Perlin noise is, but it's fine. So I said, hey, that square and vector stuff is kinda confusing, what if I try and make Perlin noise myself? But first, how do you actually smooth out random numbers? Let's say I chose 5 random numbers. 5, 3, 2, 0, 1. How can I connect these points smoothly? Basically, there's something called the Lerp function. Here's the formula. If t is 0, then it's equal to a, if t is 1, then it's equal to b. And if t is in between 0 and 1, well, you get a mix of a and b. Let's bound t to the interval 0 and 1. If we graph this function out, it's just a linear function. Basically, it just goes from a to b, linearly. If we apply that to our graph from earlier, well, then it looks very spiky, and also isn't that smooth wave, like the motion Khan Academy describes. So I found out about something called cosine interpolation. Warning, trigonometric function detected. It's actually really simple. But first let me factor this expression. We just set this value t and replace it with this expression. The reason we use this is because we want this expression to be equal to t at 1 and 0. If we just use the regular cosine function, well, then we get -1, which won't work with our Lerp function. Here's how that would look if we graphed it. We can see that it's pretty smooth now. Anyway, if we use cosine interpolation to connect these points, then yeah, it's actually kinda smooth now. Here's how that would look in Roblox Studio. We're basically just choosing random numbers and using cosine interpolation to smooth the transition, but how do we actually turn this into 3D? Also, I used math.floor to round the transitions down and make this blocky effect. Well, if we generate a bunch of these waves and space them out, then we can see that we could just do cosine interpolation between these points, looking at it in the x-axis. Basically, you take these waves and then we just connect them together with more waves. And yeah, that's basically it. This probably isn't Perlin noise, and I should probably learn actual Perlin noise. Also, I found out that Roblox already has a function for making Perlin noise, it's called math.noise. So yeah, this whole idea was stupid anyways. Goodbye, enjoy this showcase at the end. It's actually really amazing to see how math works.